We're looking here at a surface weather map that shows us sea level pressure, and what's being shown in the contours are isobars, or lines of constant pressure. And we're looking at the Northwest, and this is from a date back in February of 2012. And what we can first do when looking at a map like this is to try to identify where the low and the high pressure centers are. And what we can see here is that across northern Montana we have a surface low pressure. It's a 992 millibar low pressure. And then our surface high pressure is located here off the coast of northern California. Okay, so we can see the sort of overall gradient of pressure from low to high. And if we think about what the forces of motion are at play here, we can consider a few different lines. The pressure gradient force is always directed from high to low pressure. So our pressure gradient force is directed in a fashion that looks something like this, right? So it's going sort of in a west-southwesterly direction. And then we have the Coriolis force, and the Coriolis force is going to want to divert flow to the right of motion, or basically go perpendicular to that flow. However, what ends up happening near the surface is that we have friction at the surface. So friction has the effect of reducing the influence of the Coriolis force, and what ends up happening is that the flow actually will cross the isobars. So the flow will go from high pressure towards low pressure, but in doing so, what ends up happening is that the flow ends up actually crossing isobars and moving around the surface low pressure. And if we draw more and more of these lines, what we'll end up finding is that the flow ends up spiraling outward from a surface high, and it ends up spiraling inward towards a surface low. So the flow doesn't directly flow exactly towards that low, otherwise the low will fill in and it will no longer be a low pressure, and likewise for the high. But what we can see here is that we have this sort of counterclockwise flow around the low pressure center, and it spirals inward. And likewise we have clockwise flow that spirals outward from the surface high pressure. We can pay attention to a few of the areas of interest here where we see very strong gradients in sea level pressure, and these are going to be areas where we might expect intense winds, and they actually are quite intense on this day in particular. And the wind direction in general here is westerly across much of Idaho. And on this particular day we observed winds locally that were in excess of 60 miles per hour.